We're almost wrapped up with our idea of forming a toolkit of reasons we can use to build proofs, at least in the beginning of our journey. We're going to build more and more of these reasons as the year goes on. But the last thing that we're going to talk about, and we've seen this a little bit, is using triangle congruence theorems, and then corresponding parts of congruent triangles are congruent, or CPCTC, in order to prove things. So let's go back to proof that I made 2 videos ago, except I changed it a little bit. So I've got this diagram here. Remember that we had already been given that these 2 sides are congruent, and we were already given some tick marks there. So we had 2 given statements, and we also used the reflexive property of congruence to say that this 3rd side was congruent to itself. And the one change that I made is I changed the statement that we need to prove. So I went to prove that angle A is congruent to angle C in this diagram. So we don't know anything about the angles at all. So that's going to make this statement, well, I don't know about hard to prove, but it'll make it interesting to prove. All right. So what we've got in the proof that we set up to this point is that we've got these 2 sides are congruent to each other. These 2 sides are congruent to each other. And we've got this 3rd side, which is congruent to itself. So we've got these 2 triangles, that one on top and this one on bottom, which have a 1-tick side, a 2-tick side, and a 3-tick side. So that's enough information for us to conclude that the 2 triangles are congruent to each other. So I'm going to put that in here. So step 4, I'm going to say triangle ABD is congruent to triangle. Now we did an IXL where we practiced coming up with the correct name of the congruent triangle. We need to make sure that we've got our vertex names correct. All right. So when I'm going from A to B to D, the first thing I'm doing is I'm starting E in the corner and I'm following the 2 tick mark side and then the 3 tick mark side. So what I mean is that when I write ABD, A to B to D. So when I name the same path in the lower triangle, I'm starting from the middle point, which is C, and the 2 tick mark side and the 3 tick mark side takes me from C to D to B. So that is the correct order to label the second triangle to make sure that we're establishing our congruence correctly. And based on the IXLs we've done before, what's our reason for that statement going to be? Well, we've got the 2 triangles that they're made up of. We've got each one of them has a 1-tick side, a 2-tick side, and a 3-tick side. So the 3 pairs of sides are congruent to each other. So we can say the Sss theorem, or just SSS. All right, so this is a little bit like some of the reasons we were talking about in the previous video. So there are reasons like given or the reflexive property that we can just stick into a proof without looking at any of the prior statements of the proof. Then we had like statements where we were talking about alternate interior angles or corresponding angles where we needed to have one fact that was already established. We can only talk about alternate interior angles being congruent if we already know that we've got some parallel lines in that diagram. So when we talk about the SSS theorem, how many reasons do you think we need to have ahead of ourselves in the proof? Well, we need to talk about 1 side, 2 sides, and 3 sides. So we need 3 different congruent statements. And so here they are. Here are the congruent statements talking about the 3 sides. We would be doing the same thing if we were using the SAS theorem, which we've already talked about, or any of the other congruence theorems that we were talking about. Each one of them we're going to see need 3 pieces of prior evidence in order to establish the congruence. All right. So this is a cool thing to see, that this triangle is congruent to this triangle, but it's not what they wanted us to prove. They want us to prove that angle A is congruent to angle C. So what do I know about angle A and angle C now? Well, I know that these are both angles of these two congruent triangles, and they correspond to each other. A is the first letter in this triangle, and C is the first letter in this triangle. So they're corresponding parts of congruent triangles. And so therefore, I can conclude that these two angles are congruent to each other by CPCTC. Corresponding parts, so they're corresponding parts of these two triangles which are congruent. Corresponding parts of congruent triangles are congruent. So those parts must be congruent because the triangles are congruent. So once again, we've got a statement that is valid, but it needs to come after some statement that's talking about triangle congruence. Okay, so we've seen a whole bunch of different reasons. Let me get out my list of all of them. We've talked about using given as a statement. If statements are given to us at the beginning of the proof, either in words or in the diagram. We've talked about the reflexive property, which talks about how a side or angle is obviously congruent to itself. We've talked about the vertical angle theorem, which says that if two lines intersect each other, the angles on opposite sides of the vertex have to be congruent to each other. We've talked about how if we have a statement that uses a definition, we can then replace that statement with what it means in geometry language, and then we're going to appeal to the definition of whatever vocabulary term we just used. We've talked about how all right angles are congruent to each other. We can use that as a reason, but we already have to know that there are some perpendicular lines or 90-degree angles in the diagram in order to conclude that. We've talked about the alternate interior angle theorem and the corresponding angle theorem, so that if we've got parallel lines cut by a transversal, we can say that the alternate interior angles are congruent or the corresponding angles are congruent. And finally, we've got our triangle congruence theorems like SSS and SAS, and we've got corresponding parts of congruent triangles are congruent, CPCTC, which we need to, in order to talk about two triangles being congruent, we need to have three congruence facts regarding those triangles. And then to use CPCTC, that needs to come after knowing that we have congruent triangles. So that is a pretty big toolkit, and it's going to be big enough for us to prove a whole bunch of really interesting things. So we will see examples of that coming up in the next couple of videos.